Hey folks, thanks for coming for this talk, which is CephFS, 3 easy pieces. I hope it's easy. I see quite a few happy faces, some not so happy faces. I'm, I'm getting the feeling that I'll get mixed questions, which we are already prepared for. So nice. So I'm Venky. I lead the FS team at IBM, and I have my colleague Patrick here, and wave hi. And let's get this kicked off. Off to Patrick to start off.
Okay, so for those who are not already familiar with CephFS, I'm just going to give a very brief overview of what it is. CephFS is a POSIX distributed file system. It's endeavoring to behave exactly the same as you would expect for any POSIX local file system. At the time it was conceived, CephFS took a novel approach to organizing metadata and data for within a distributed file system. It separates namely by separating them into two parts. The metadata server handles all metadata for the file system, and the clients talk directly to the data pool to do reads and writes. So clients send metadata requests to the MDS, as in the diagram, they're sending like open, makedir, lister to the active MDS. The MDSs, which there may be more than one, cooperatively maintain the entire directory tree of the file system, at least what is in use by clients. And so in the diagram, we have two active MDSs, and they are authoritative for different parts of the file system tree. Each MDS processes requests from clients for their part of the directory tree, writing it to a journal, which is represented in Rados on the metadata pool. The MDS is also responsible for maintaining cache coherency with clients, and clients also cooperatively cache metadata locally with the MDS's permission by the MDS handing out what we call capabilities, which you may have heard of. And that gives the client permission to do various things locally, like cache metadata, or even modify certain metadata, or being allowed to read or write to a file, or cache data from the file, or buffer writes to a file. And so again, clients with those capabilities are allowed to directly access the data pool doing those reads and writes. Next slide, please. Oh. Okay, so just as like a brief overview of some of the history of CephFS, we actually had a talk yesterday about this, if you want to see something a little more comprehensive. But CephFS actually has a fairly long history. We're almost at 20 years since its first academic paper. Back in 2006, Sage published his Ceph, a scalable high-performance distributed file system paper. And then sometime after that, after graduating from graduate school and getting his PhD, he at DreamHost, one of his companies, he started Inktank, a startup. Some Inktank had a support model for Ceph and was an open source first company for Ceph, and they did a number of things during that time, including introduce support for CephFS in the kernel, adding snapshots during that time, and then around 2014, Inktank was acquired by Red Hat. CephFS started to get on the radar of a lot of folks around in 2016 when we declared it stable in the Joule release of Ceph. Coincidentally, that's around the time I joined the team. In 2017, we put out the Luminous release, which was exciting because we declared multiple active metadata servers stable. We also introduced static pinning, so you could pin certain directory trees on a particular MDS active MDS. And then in 2019, with the Nautilus release, we introduced NFS clustering, a number of caching improvements to the MDS for large production deployments. And we started to introduce the concept of CephFS volumes and subvolumes, which are used in higher level volume management APIs like Ceph CSI and Manila. Manila is actually where a lot of that work started, and then it got promoted into a first-class concept in Ceph. Then in the Pacific release, we had a very large number of things that we put out. As you can see in the slide, CephFS top, snap scheduling plugin, NFS gateways were considered stable. We introduced multi-MDS scrubbing. So if you launched a scrub on the ring 0, it would also percolate to all the other rinks and scrub the entire file system. We introduced ephemeral pinning and Ceph Token, which introduced Windows client support for accessing CephFS, similar to Ceph Fuse. CephFS Mirror debuted, and also FS-Script was supported in the Linux kernel client. More recently with Squid this year, some of the notable improvements we've made that we'll also talk about is Quiesce, which allows you to quiet an entire directory tree so that clients can't do any manipulations on it. Log trimming improvements, how the MDS regularly does log trimming in response to the client workloads is now much better, and the automatic metadata balancer is now disabled by default, preventing a number of surprises that users have come up against when they manipulate max MDS without exactly knowing what that does. And then, of course, we're going to be talking about what's going on in Tentacle, which is not yet released.
All right, thanks for the intro, Patrick. So you probably saw a version of this in the keynote yesterday, but I'll just go through it really quick. So for the Squid release, we had these are the marquee features that made it to the Squid release. First is the Quiesce feature, which was developed to support crash-consistent snapshots. So we can take snapshots on CephFS directories, but without the Quiesce and all the halting I/O stuff, it's how do you take snapshot on multiple directories and ensure consistent. So you can think about running a database on CephFS, having the journal on one particular directory, and it's the database data on the other directory, and then you need to take snapshots of the whole database, right? So how do you do it? So that's where crash consistent snapshots comes in. There have been really nice improvements in the way we do MDS journal trimming. So users of CephFS have probably know about the much dreaded MDS log behind on trimming. I can see some folks smiling. Yeah, so that shows up quite a bit. So we took time and effort to fix that up. That's really nice work that has gone in, and hopefully you'll see less instances of those showing up in Squid and further releases. Another pain point was the automatic balancer, the default balancer, which would misbehave. So if you have a multi-MDS cluster and no subtree pinning, the default balancer could misbehave and choose to split a subtree and hand the subtrees over to the other active MDSs for load balancing. But what would end up happening is it would create lots of these smaller subtrees, and MDS cluster with lots of subtrees scaling to thousands was always problematic. So that would bloat up the MDS journal, slow down trimming, slow down client I/O and everything else. So that has been disabled by default, and the approach there would now be to use ephemeral pinning or static pinning. Coming to the upcoming Tentacle release, so these are the marquee features again. So there's lots of nice stuff going into Tentacle. starting off with like case-insensitive directory trees. So this is particularly for the Samba environment. So you would know like Samba, the file system, any POSIX compliant file system is case sensitive. So an uppercase foo is different than a lowercase foo. But Samba environments do not like that. They work a bit differently, where if a Samba client tries to create a file with lowercase foo, so all lowercases, it has to first check if there is another file which could possibly be uppercase foo or any other combinations of that, like lowercase f, uppercase o, and lowercase f. So you can see what Samba is trying to do. To validate that, to check that there is some other file which could be of a different case folding, it would do a scan of the directory, and then it would check if there is at least one file which that file would map to in terms of case sensitive. So that is like a big performance degradation, and obviously we don't like that. So there is work to not do that and improve performance by not doing those retears, directory scans. The other upcoming feature, which should really improve the way CephFS handles hard links, is the referent inode stuff. So now, right now, CephFS supports hard links, so you can have hard links between directories, the whole POSIX compatibility stuff. But the way hard links are tracked in CephFS using global snapshots is not scalable. We have frequently seen issues where the global snap run is a limiting factor, and not only the limiting factor, but also the source of bugs, which recently, the most nastier ones is having the MDS to go read-only. So with the efficient hard link management, the plan is to get link of global snap runs, and we'll talk about this a bit into detail of how we are doing this. But that's another marquee feature that you should be looking out for. And finally, the user space FS-script stuff. So the kernel FS-script work landed like 2021-ish. And we'll obviously like the user space to be on par with, user space client to be on par with the kernel client. And so Chris Hoffman is working on it, and we'll link his talk somewhere in the further slides, so watch out for that. And finally, there's a contribution from the NFS Ganesha folks for making the I/O path in the user space client, libCephFS, as asynchronous. So that's getting NFS Ganesha to be much more performant. So we'll talk about a bit more of that, and we also have a lightning talk about that. Off to Patrick.
Okay. So yeah, just pivoting over to the MDS. And to get a little bit more detail of what we have done. This is going into the Squid release. So one of the things that the MDS does, I mentioned earlier that it journals all of the metadata operations to the metadata pool. And the MDS logically divides the journal into segments, and each segment begins with a particular type of what we call an event. And that is the subtree map, which contains all the metadata necessary to construct the subtree map when the MDS boots. And the MDS operates with the constraint that whenever it's reading the journal, the first event that it has to read is the subtree map. Otherwise, it doesn't know how to start. When you have many subtrees, think hundreds, thousands, the subtree map can get quite large. And what we would observe is that, especially if you were doing a really aggressive pinning strategy, that the MDSs would have very bad performance, because generally the MDS would be spending most of its time writing down what the subtree map looks like in the journal. So And the frequency in which it writes the subtree map depends on the number of events it's doing and also the size of the segment. And when the subtree map gets really large, it dominates the size of the segment. So you don't write as many events, and you're writing the subtree map more frequently, it just gets worse and worse. So what I did last year was introduce a new segment type, eSegment, which is what we call a minor segment, which allows us to journal the subtree map less frequently, and while also delineating segments and grouping operation events like changing metadata on a file or making a new file into these smaller segments that are not necessarily beginning with the subtree map. And one of the things we had to do to make that work, to operate with the constraint that the MDS always starts with the subtree map, is that whenever we're doing trimming in the MDS, we always trim up to what we call a major segment boundary, which in this case would be the subtree event. So if you, there has been actually a recent bug relating to this that I think Venky fixed, where if you have a number of minor segments and there's no viable subtree map event to trim to, the MDS can actually get behind on trimming, but we've since fixed that. But anyway, this now lets us write the subtree map much less frequently, and it's improved performance a lot for certain workloads, including IO 500. And if you want to meet someone super excited about it, go talk to Mark Nelson. All right, next slide. Okay, so we mentioned Quiesce earlier, coming for, well, it's in Squid, and it's coming in Tentacle too. And what this is meant to support is crash consistent snapshots. So within a distributed file system, you have clients that are potentially operating on different machines, and they potentially will talk to each other outside of the context of the file system, and they're going to be doing, like, consider, for example, a distributed database. And they may be recording transactions with fsync in the file system and telling another client, hey, I did this thing. When you have snapshots, you need to take a point in time view of the file system. And applications can get confused when you take a snapshot and one client did more things than it was supposed to after the snapshot from one client's perspective, and vice versa. And part of that is whenever we do a snapshot in CephFS, we tell the clients, hey, we did a snapshot. We don't also necessarily wait for the client to say, all the clients to say, I'm done, I acknowledge that the snapshot's been created. And that's largely a consequence of how snapshots work in Rados. So we need some way to get the clients to stop their I/O and their metadata operations on the file system tree that they're operating in that we want to snapshot in order to safely do it, such that none of the clients are manipulating the file system at that point in time, so that we can all agree on what the state of the file system is. So what we have now is this new Quiesce mechanism, where you just give a particular directory in the file system, and the MDS will, across all the ranks, recall caps from the clients that would allow them to mutate metadata or file data, and then hold that state, allowing you to take a snapshot. When the snapshot has been completed, you can then release the Quiesce, and that allows the clients to reacquire their caps and continue their work. There is an admin socket command for the MDS that allows you to actually run that manually, but we do not expect you to do that in practice. We have a interface in the volumes plugin, which is much nicer porcelain layer over the raw command that we would expect to be used routinely, and we'll talk about that one later on. Okay, another feature we talked about, this is coming in Tentacle, but we also anticipate backporting this to Squid, is case-insensitive directory trees in CephFS. And this is, as Venky was saying, to support a Samba use case, which expects to present a case-insensitive view of a file system to its clients. And the way this works within the context of the MDS is it's leveraging a directory entry metadata called alternate name. And this is a fairly unusual concept within file systems in that the alternate name metadata directory entries don't normally have metadata other than an inode number and a name. So we're now attaching that we have this alternate name metadata attached to files or to directory entries, and we store what the actual caseful name is in that metadata. And that metadata is actually manipulated from the client. The MDS doesn't really care what it is, because all it really cares about is the actual name of the file. The client will do the case folding itself, and there will be global agreement about what that case folding is with some additional metadata that the MDS distributes to clients. And so the name that the MDS uses is the case folded name, but the alternate name metadata allows the client to reconstruct what the name should be and present that up to the application, which in this case, from the CephFS client perspective, would be Samba. So you can expect that to come in Tentacle and at some point in Squid.
All right, so talking about another marquee feature for Tentacle is the efficient handling of hard links. So I did mention about how hard links are currently managed in the MDS with all the global snap realm stuff. So just touching about that a bit, the global snap realm is there for to hold all hard links that have been created in the file system. So if you have even one hard link in the entire file system, there's a global snap realm. And essentially what it does is to track the hard link. In the sense, in CephFS, we can, given a hard link, we can obviously find what it's linking to, but not the other way around. So if we have the first file, we can't reach all the links that are pointing to it. So if you don't have that, the only way to figure that out is to store hard links somewhere. So right now, that's the global snap realm. And this is essentially for hard links and snapshots to play nicely. So when you take a snapshot for a hard link file and modify the original file, you expect when you read back the hard link in the snapshot, you expect the old data to be there. So we have to do all these kinds of gymnastics or jugglery around with global snap realm. So this is the problem that we have. And so to solve that, there's a concept that's introduced in the file system in CephFS called the referent inode. Now this is like an ongoing work, but we hope that it will land in Tentacle. There's a good likely chance it will land in Tentacle. But this has been a year-long effort by my colleague Kotrish, who unfortunately couldn't make it to CephFLCon this year. But essentially, the concept of referent inode is to have the hard linked inode as a full inode rather than just being a link pointer. I mean, if you think about it, it's kind of on the contrary because hard links are just pointers to the original, to the actual inode. But we're kind of flipping that out and having like a full-blown inode for the hard links. But the semantics still remain the same. Internally, we work up the machinery and mechanism to have the hard link having the same inode number, but just for storage purposes and to play nicely with snapshots is why we need a different inode for the referent inodes. Does this increase the storage size? Yes, it does, but we hope to keep that to a minimal by keeping only the essential fields that required to get rid of the global snap realm and move everything, whatever is required, to the actual hard link tie node. So yeah, once this is done, we'll be able to say goodbye to the global snap realm and hopefully goodbye to a bunch of bugs that are lingering around for long. Yeah, so hopefully that gets done. Yeah, positive about it.
Okay. So we mentioned that there was kernel client support for FSCrypt. That was merged a while ago in Linux 6.6. That works by using the alternate metadata or alternate name metadata I mentioned earlier for case-insensitive directory trees. We're leveraging that same, or rather, case-insensitive directory trees is leveraging the alternate name metadata that we use for FSCrypt. And the alternate name metadata was necessary to handle the encryption of a directory name that is potentially longer than the maximum directory entry name that's allowed by CephFS, which would be 256 characters. So that's why it exists. Anyway, that is now a fully supported way of encrypting data in CephFS. And the actual setup for doing an FS-crypted volume in the kernel is fairly simple. It uses the FSCrypt user utility that we do not develop. That's something that Google maintains. And you can use that to encrypt a CephFS tree the same way you would with like an ext4 file system. And there's an example on the slide. And then also in the Tentacle release, we're planning to also support user space FSCrypt. That's been a long effort being led by Chris Hoffman, who's giving a talk later at 2:25 p.m. Be sure not to miss it. On porting the FSCrypt library that exists in the kernel over to user space, which does not exist anywhere. And so that we had to re-implement that, and the same primitives in the protocol used by the kernel talking to the MDS are being used in user space, and they're fully cross-compatible. So you can say encrypt a user's in the user space and then decrypt it in the kernel if you need to.
All right, so you also touched upon the asynchronous I/O part, which is in the user space client. So I should obviously mention about Frank Fils from the NFS Ganesha team, who did the work for us. So essentially, the asynchronous I/O path in user space client is just the working with like callbacks. So NFS Ganesha, when it wants to do do a write or a read from the user space client, passes a callback that gets registered way into the objector. And when the I/O is done, it gets registered. The callback is invoked. This has resulted in a good amount of I/O throughput improvement in NFS Ganesha. That's what Frank Fils reported. We don't have numbers, sorry for that, but it did result in a noticeable improvement. And Dhairya has a talk about this, a lightning talk. Please find the link there at 5:15 p.m. And thanks for the diagram, Dhairya. Wave hi. So please try not to miss that talk. All right, so the final piece of the 3 easy pieces, the Ceph Manager plugins. We have a host of them in CephFS, all the supporting modules, all the interfaces that we have. In the past few years, we have been having reports of these scalability issues with some of these modules, especially the volumes plugin. Given that the volumes plugin essentially talks to a file system, it's a client, CephFS client, that talks to the file system to support creating subvolumes, taking snapshots, deleting subvolumes, and a host of other operations. And because some of these operations can take a finite amount of time, and when the load is really high on the Ceph Manager, and lots of requests are being done on the volume client, there's a backlog of operations that gets held up in the Ceph Manager, and that causes all sorts of issues like PG starts being delayed, causing nervousness in operators. So there's some work that has been done to relieve of this backlog by having a separate a queue for each of these plugins. That has not totally eliminated the issue, but for the time being has at least have some noticeable improvements. But I think so. There's effort to improve things on the Ceph Manager side for all plugins in general, rather than for the volumes plugin itself. But this is a noticeable feature, and hopefully we get less problems with the volumes plugin. Quires interface. Well, Patrick already spoke about it. I'm not going to go into much detail, but this is how the interface looks like. You can set a quires ID and include the directories which you want to include it in the the quires set, and then take snapshots, and then release the quires set. And this is implemented as a manager module again, and internally uses calls to the MTS to take to do quiescing and create these crash consistent snapshots and finally release them. Yep. The docs are there. I'll link it at the end of the presentation. So please feel free to go through that. There's nothing much, but this is how the interface looks like. Okay, so yeah, this is interesting and a bit controversial. The manager volumes is essentially when it's invoked to create CephFS subvolumes, it creates a bunch of directories in a particular layout, which we called as, and each of these directory paths or these layout are version. We started off with something called as legacy, which I think were used by OpenStack Manila, and then for supporting Ceph CSI and other consumers, we moved to V1. Then to support availability of snapshots even when subvolumes are deleted, we move to V2. And it looks like we are getting more consumers which are trying to call us in various different ways, and we want a V3. So work has been done, at least on the design level, to have the finale subvolume. I hope I'm pronouncing that correctly, but we hope that once this is done, there is no more changes to the subvolume layout. And so there's work planned for that. Let's see if it lands. Future work. So the referent inode work that I spoke about is setting up the stage for doing fast clonal layering. The layering work, if you know how RBD does snapshots and clones, it works on layering where not the whole image is copied. So right now, if you want to clone a particular snapshot in CephFS, it's a full copy, which obviously scales badly with the number of files, with the size of the snapshot. So once the referent inode work is done and merged, the next thing that is of utmost importance is fast cloning. So RBD style cloning, instant cloning, that will build on the referent inode work. This is post Tentacle, by the way. And the other thing that's in our radar is quality of service, QoS. Every once in a while, someone drops in on the users list to talk about, to want having QoS. I should mention that there is already a PR, a change by folks at LineCorp. If somebody from LineCorp is here, thanks for that. But it's waiting to be reviewed, and I think so. It's a little bit incomplete, but we'll try to address all the missing pieces of the puzzle. And once that's done, hopefully we'll have QoS. This is based on DM clock, by the way. All right. That's the end of the presentation. Happy to take any question and answers. Yes.
Is
You want to take that, Patrick?
Yes, there'll be. We've not yet made them compatible, but we know how it'll work. It's basically layering it like an onion. That is, one name wraps another. So the encrypted name would always be the alternate name. You would never have a clear text name in the alternate name. So you have to decrypt it, and then you can read the caseful version of the name. Okay. Any other questions?
Yes? So the question, okay, so the question seems to be if you're not using subvolumes or using like the legacy subvolume and you want to move to one of these recent versions, how is that done? That should be automatically done by the manager volumes module. So when you first access a subvolume is when, if it identifies which version is it and automatically upgrades it to one of the recent versions. So that's been taken care at least till the V2 version. Yes.
Please. So the question is, do clients get notified if a quiesce happens? No, they just get their caps recalled, which looks like a normal cap recall to from the client's perspective. There is a potential performance improvement we may explore where we actually ask clients to stop doing I/O and metadata I/O on a directory tree so that you don't actually have to recall the caps. But at the moment, it's unclear if that's worth the effort.
Somebody did send a change for that, but oh, sorry. Okay, so the question is CephFS mirror doesn't support or does not synchronize exadders, user exadders or any other exadders. Yes. At the time of writing, it did not do it because it was not required. But yeah, I think we do have a tracker and a potential fix for that, but you need to be reworked. But there's not something that is extremely difficult to do. It's pretty much straightforward, so you might end up just taking that change. Yes,
Yeah.
please. Sorry.
Well, sorry, I'm not hearing the question very well. Can you speak up more?
So if I got that right, you want to like identify clients which are doing heavy metadata workloads, specifically identify and have some kind of an interface in the MDS to report them. Oh, it seems to be like metrics of clients, client-side metrics. Yeah. Yes.
Oh, so I think what you're, so the problem I think that's being expressed is that if we have metrics for the clients and we have client IDs and we know that 50 of those client IDs are on a particular machine, we don't know which mount corresponds to those client IDs. Okay. Well, if that's not visible in the porcelain layer, we could do a better job of that. That is, the porcelain layer would be CephFS top to actually look at those things. But the option you have available to you is to just list the sessions on the MDS and actually look up where the client ID metadata. And the metadata would include what the mount point is for the client. You have multiple clients with the same mount point? Is that because they're in containers? Oh, that's fun. So I think perhaps you want to be able to include an additional piece of metadata in the mounts that would allow you to distinguish them. Yeah.
Yeah, I mean,
We'll talk more about
these
that.
clients should actually be forwarding some piece of information for identifying themselves to the MDS. This is the same problem we have with NFS Ganesha, actually. Ah. Okay, okay. Kind of get that, but not totally. Yeah, we should talk. Yeah. There's someone raised a hand from here, or was it a stretch? You can go.
Okay, it's probably out of your scope, but do you have any update on the VirtIOFS Manila driver? Maybe you don't know about it.
The what
I
Manila
don't.
driver?
VirtIO.
VirtIO.
Weird.io?
VirtIO.
VirtIO.
Sorry, VirtIOFS.
So the question is, do we have any update on the VirtIOFS Manila driver? I think the answer is no. No, we don't.
Yeah, out of scope.
Any other questions? Folks eager to go to lunch? Join the madness?
Yeah, everyone's hungry, so I'll let you guys go. Thanks for dropping
Thanks,
by.
everyone.